stop because I just wound it. That's a good runner. But there's a hairspring, and that makes it so the balance wheel can turn one way and then turn back the other way. And then there's, on this watch, there's a little pin. It says this is a double roller, and the roller it's a flat plate that has a pin on it made of ruby, literally rubies. And then as that spins around back and forth, as it's going through its arc, it pushes a little fork, and it goes back the other way. It pushes the fork the other way, so you end up having the roller with a D-shaped ruby. And there's the pivot. And then I'm going to draw this way out of scale. There's a escapement. Boy, it's been a while since I've looked at one of these. It's going to be kind of like this. I'm going to draw very poorly. It's going to look almost as bad as a Wikipedia drawing. As the balance wheel spins, the roller underneath it spins, and and this is pivoted. There's a pivot right there. And as it spins, this will flick it this way, and it comes back, it'll flick it that way, and that'll flick this way, and then it comes back, I think I had it backwards. First basically what it does is this will flick back and forth also. And that puts
and this is all Newton's first law, the motion stays in motion and all that, or no? Oops.
Oh, sure. You want me to go setting up the three laws?
No, I don't care about that.
Yes,
this is all pendulum.
It's inertia.
Right.
No, it's inertia.
Right.
It's, in a way, it's almost like a rotating pendulum.
And the reason why
it's like a kid on a swing, because a kid on a swing, it's just that instead of the pendulum going a few degrees, it'll spin all the way around and come all the way back. So it really is a pendulum, and instead of driving it by pushing the pendulum, this fork will actually send impulses to the balance wheel. I always talk about the balance wheel pushing the fork, but it's really the fork pushing the balance wheel.
Can you tell me in this diagram here where the pressure from the winding and then
that's what I was just going to do.
Oh, I'm sorry.
There's going to be
where's that push?
There's going to be another gear here, and I'm going to draw these the wrong way. And your watch, it has these little tooth-shaped spikes on them.
Tick.
And this is the escapement wheel. And the escapement wheel
is attached to this swirly guy.
Well, no, actually, no. This swirly guy goes right.
That's what you wind, right?
Goes right here. Nope, no, that's the hairspring. Hairspring is on the balance. Here, I'm going to put the balance here. I'm going to put the screws.
Okay.
The screws on the balance, which if you change anything on the balance, you're supposed to adjust these screws, or else it'll run a little funky.
It makes sense. Because these are all dictating
and this is
the
a
oscillation.
Bimetallic balance, so odds are there's actually going to be a cut in it somewhere. Generally, in a bimetallic, there's a cut in it somewhere, so as the temperature changes, the wheel will change its diameter slightly. And as it changes its diameter slightly, it'll adjust. This is how cool this stuff is. Some of this stuff goes back to the 1780s with...
That's unbelievable. It accounts for expansion and contraction?
Yeah. No, well, expansion with temperature.
Yeah.
Because it'll... because it's got to adjust for temperature.
Well, why don't you, if you could, bounce into the concept of the 5 laws of the railroad watch and how they get inspected.
Hold on. As this will have a gear. Usually, I have to visualize. I've taken out dozens of these. I have to visualize where the gear would be. On this. There should be a gear on the end of it. The small gear at the bottom, and that small gear at the bottom will drive a larger gear, which will drive a larger gear. Which will have a small. These gears are all kind of doubled. There's a outer one with a small one, and the small one turns the outside of the next one.
Sure.
And vice versa until eventually you end up going to the main wheel. So if you look at it, sometimes you'll see on Wikipedia something you'll actually have this going out in a straight line, which nobody builds a watch that way, because what they do is they curl the wheels around to keep them so the main wheel in the center would drive your hands.
And the origin of the pressure that turns that first wheel is your watch.
Is the
key or the spinning of your finger.
At some point there's going to be, and this one I really would have to look at, but going to should be the outermost wheel will be the mainspring. And that's the thing you wind with the key. So that has a gear literally on the outside of the barrel, and they call it a barrel because it looks like a barrel. It's a hollow barrel. You put the spring inside.
Where's this guy in relation to this guy?
The Fusee
Yeah.
would be,
If you don't mind.
if this one or this one, there'd be, you can't see the barrel on this? No, you can't. See, if I had this open, you could see the barrel. The barrel, if you look at an uncased watch, more modern watch, you usually at the outside of the plate, you'll see these little teeth sticking out, and that's the barrel.
Okay.
So on this watch, it's a Fusee. So on top of the barrel would be the Fusee mechanism.
Got it.
The
Right
layer
there.
cake would be right on top of
Right
it.
where it starts.
And that's one reason these watches are thicker.
Okay.
They could have made these thinner, but the Fusees have to be thick because they basically have to. They have to be thicker because they have the chain.
Forget about this for a second. Tell us about the history of railroad watches and why they're
And
important.
also with the Fusee, it's probably going to be the chain is going to go to one of the wheels. Instead of the gear driving this wheel, it'll probably be the chain driving the wheel. But
Interesting.
Once again,
Really?
it's.
That's interesting.
I have never taken apart a Fusee watch,
That's all right.
so
No one's gonna take it apart
I'm-
based upon this.
I don't want to say I'm kind of
No.
talking out the side of my mouth
Out of your
there.
ear.
Yeah.
So what about the
that
railroad?
covers
They didn't have
most of this.
switches, so that's why the time had to be perfect. It wasn't just
Okay,
because the train's
first-
going to leave on
First of all,
time.
everybody had pocket watches until 20s.
That's crazy.
Lindbergh had a one custom made for him by Longines. I have a Hamilton, one of their earlier, considered to be one of the most beautiful watches made, Piping Rock Hamilton, and that was introduced in the early 20s. World War I, people started to take pocket watches and have jewelers solder on lugs and then wear it on a wrist. So whether pocket watches, whether wristwatches precede that, I'm sure they did. But that was a common conversion. So you see converted watch from the 20s. You see a lot of converted watches that are done recently, so people could sell them more easily. Anyway, so railroads, they had a lot of problems with time because part of the problem with railroads is they didn't have any standard time. That's why we have a standard time now, because you went by local time. So local time in New
crazy.
York would be off several minutes from local time in Mineola. And that's why they tended to have these trains run into each other. And they also didn't have electronic signals.
That's amazing.
So once they went to standard time, which I'm not sure when that was, they, either before or after that, your railroad conductors had to have accurate watches. At some point, I'm assuming 1870s, 1880s, I'm probably going to guess 1880s, they standardized to the point where a railroad man had to carry a watch that was adjusted to 5 positions. 5 positions means pendant up, see, it should be pendant up, pendant down, flat, upside down. I think it's, it's pendant up, pendant right, pendant left, unless I have the reverse for the camera, face down, dial up.
Amazing.
Those are the 5 positions. I have a watch that's adjusted 7. It was the same movement as the Omega Speedmaster, and the manufacturer that designed that particular movement, they made it run probably 10 or 15 watches, a little underappreciated, but they adjusted them to 7 positions. And then they're usually adjusted to temperature as well.
Amazing. And that would qualify it as a rail.
Well, the railroad started to require that you have a watch that met those standards, and it had to be periodically reviewed by some railroad personnel. They'd actually test your watch. And they also designed railroad dials. And railroad dials, because people would make a mistake reading their watch, so they made railroad dials so they were basically idiot-proof and almost drunk-proof. This is a Ferguson. This is a reproduction of a Ferguson patent dial because I think it's one of the cooler looking ones.
That's gorgeous.
You could probably find out. That's easy enough to research when they came up with these dials. I'm assuming they went to 5 positions required and large Arabic numbers, probably 1880s or 1890s. I'm pretty sure it was well before 1900 though. Could be wrong. When I read it, it was probably at least 5 years ago. And I'm trying to think of what else. Also a railroad watch. In order to change the time, you couldn't just pop up your knob and change the time because they didn't want these imbeciles wrecking chains because they accidentally changed the time when they wound their watch. So you had to.
Really go.
They're called lever set.
Go at it.
You had to open it up. You had to pull out a lever, and then you could change the time.
That's pretty drunk proof. That's hard.
And that was more because people would wind it. You'd
Sure.
wind your watch periodically. You wouldn't just wind it once a day. And then you close the lever, and then when you screw the front on again, your lever's now set. Now remember, since it was adjusted 5 positions, it should be keeping time to 6 seconds a day,
Wow.
and 6 to 10 seconds a day, which means you could set it once in the morning and put the dial on and not have to worry about it again.
Way cool.
And this is a chronometer, which is, chronometer.
It's a stopwatch?
No, this is a chronometer. A chronograph is a stopwatch. That's what the other ones are. This is a 54, 55 Omega. And you see at the top it says officially certified. And the Omegas have a little observatory
Oh, because they got checked
thing on the
out.
back because they used to check them at the observatory.
Right,
And they would literally check these things.
right.
So this
Certified.
this one's a chronometer, which means it'll keep within plus or minus 6 seconds a day, regardless of position and temperature.
Can you tell us about the aviation clocks that you got? You got one from Corsair or?
Yeah, it's a Hamilton Elgin. They got together to design it jointly at the beginning of the war, right before the war. It's
Crazy.
3750, if I remember correctly.
Does it still keep time?
And it was designed for aircraft use, so it was designed to high standards. The things they're almost indestructible. I mean, basically nobody services them, and they keep running.
But what winds them? They have to be wound. Okay, so they do it after.
Wind lever.
So that's part
Just
of your.
like when you fly,
your
you have
pre-flight.
to pull out. You have to adjust
Yeah.
your altitude,
Yeah. So you
or
do
rather
the same
your
thing.
air pressure.
Got it.
So there's a wind on it. There's also, because if you were flying instrument, you'd have to time the legs.
Sure.
There's a stopwatch built in.
And also your fuel. I
Right.
think that's where they determine whether.
And
you're
it
out of
also
fuel.
had a continually running civil time clock
Amazing.
on the face.
Just absolutely ridiculous.
And that has 2 really large barrels, which means there's 2 mainsprings in it. So if one snaps, it keeps running.
Redundant.
And also has enough power to rip your finger off, probably, because they're
Just crazy.
2 barrels. It's a miracle they don't wear through the jewels on them, but I haven't seen any damage on them.
That's amazing.
Most of the ones I've seen have been dry. I've had a couple of them.
Very cool.
They're really, I really like them. They're also 24-hour watch, 24-hour dial, which I have a 24-hour dial watch. I found them very difficult to read, so that I'm going to get rid of. But the aviation watches, those clocks are great. They also had ones made by Jaeger, Swiss made. I think what they wanted to do was have Hamilton.
Who did the Swiss make it for?
Oh, they make it for anybody.
Yeah, exactly.
Yeah.
They gave it to the Germans and the Americans.
I've worked on some Bullovas and Hamilton. There's no question the Hamiltons are superior.
Oh, really?
Hamiltons are phenomenally made.
Are they American made?
Yeah.
Oh,
Hamilton's made in Lancaster, Pennsylvania.
cool.
You can still get